Cool. All right. So today we are here to discuss, I believe we are going to introduce NEP 606 and 616. Is that right? And it's related to deterministic account IDs. Who would like to present on that?
I can. All
Okay.
right. So yeah, there is a single NAP 616 about the deterministic accounts. So do you want me to share the screen maybe and maybe go over the text, or I
Yeah,
don't know.
that'd be great.
This is the first time that I'm doing this.
Yeah, if you could show, that would be awesome.
Okay. Just a sec.
Yeah, just a high-level overview of the changes. No need to get too technical. Just
All right.
something for posterity, for people in the community that are interested in sort of what's going on at a high level.
All right. Yeah, the NEP is basically to enable sharded contracts, but not directly by supporting some kind of something new for these sharded contracts, but rather by just introducing a new type of account ID. And this account ID will be derived deterministically from the initial state that consists of the code of the contract plus the like the storage state of the contract, because that's basically what defines the state of the contract. Yeah, and the idea was like the idea is borrowed from Ton actually, and this is like the second largest sharded blockchain that I know. So there is nothing like specifically new here, but still I think it's worth borrowing some ideas from them because this model showed really well for their blockchain, and it fits quite nice into Near, I think. Yeah, so the usual questions that come to mind when you start to think about how to implement these sharded contracts is that like first you need to verify somehow that another contract calling your contract executes the same code, and this is issue number one. Because when you're being called, nobody tells that, hey, I was executing this code, and here's why you can trust me. For example, if we're talking the sharded fungible token wallets, where each wallet resides like I have my own wallet and some other guy has his own wallet, and these are separate smart contracts. So when you do a transfer from the sender to the receiver, the sender basically decreases his like deducts his balance, subtracts from his balance, and then the receiver adds the value that it was transferred. And but in order for me as a receiver to make sure that I really can increase my balance, I should somehow have a guarantee that the sender actually subtracted this amount from his balance. And so the only option to make this the guarantee is to make sure that the code that I'm right now executing is the same code that he was executing, the sender. And that's why we need to prove somehow that the contract that interacts with us right now was executing some specific code. Yeah, so the second question that comes to mind is that who pays for deploying all of these smart contracts? And actually, we can use the zero balance accounts for that that were introduced. I don't remember in 491, I think. I know that's the global contracts, but somewhere here, I don't remember. Yeah, so but sometimes the state can be bigger than 770 bytes, which is the limit for zero balance accounts, and that's why someone needs to pay for the creation of this contract. And the like then it comes to a question, who pays? Because if I want to onboard my grandmother to crypto and I want to send her, I don't know, some tokens, then I don't want to ask her to first prepay for her wallet contract that will hold her balance of these tokens, and the user experience will be much more straightforward if I just can prepay for her. But then if I pay for the creation of her wallet, her deterministic contract that does something, but in our context, I'm right now talking about the sharded fungible token wallets, then should I be able to then like claim back the amount of NIR that I paid for the storage costs? That's the second question. Then there is another one about what if her contract that I am about to interact with was already created, but I don't know as a sender, I don't know if some contract was already deployed, initialized or not. Okay, if I'm a human, I can do it off chain. I can just query the blockchain and say, hey, like whether my grandmother or whoever has already the wallet for the contract of wallet deployed. But then if you think about other smart contracts that like sometimes tokens are being sent and received by other smart contracts, for example, other DeFi protocols, and then there is no way for this DeFi protocol to ensure that for a smart contract to ensure that another smart contract already exists. So that's why this smart contract, when it is initiating the sending of the tokens, it should prepay anyway for the creation of the receiver wallet, of the wallet of the receiver. And now what happens if it was already like if it already exists? Then these funds should somehow get refunded to the initial sender, and the initial sender can be considered as the like the first guy into the chain of sharded interactions between the smart contracts that actually paid for everything, for creating of this particular contract, for initializing this one, and like this chain can be really long. For example, I can transfer these tokens, then I'm basically supplying I don't know, collateral to some DeFi lending protocol, then I'm getting in return some liquidity provider tokens, and then I can send them as well, and like this chain of calls can be really long, and it can involve a lot of sharded interactions, and therefore I should be the one who pays upfront for the creation, for the initialization, deployment of these contracts, and each of them could have been existing already. So that's why we also need the mechanism to refund all of the NIR tokens that I attached to for every step. And the final question is about what are the permissions on, like, if I own in a semantic way, own some sharded smart contract. For example, it represents the my sharded fungible token wallet, and I'm able to send tokens from it. Then how does it determine that I am the only one who can do it? I'm the only, and maybe if we're talking not only about the sharded fungible token wallets, or we can talk about a lot of different applications for that. And the question is, who is allowed to make some actions, to take some actions on these accounts? And it turns out that the most flexible approach in my opinion, was to let the contract decide. So the contract decides what are the permissions. It manages something inside of its storage. It can keep the owner of this contract or maybe some other roles, and that's how the permission question is resolved. And then basically this NAP is about answering all of these questions by introducing the concept of deterministic account IDs. So if we have an account ID deterministically derived from the initialization state that is over here, like this is a versioned one, but basically what we should look at is these two structs. So the initialization state of the contract is its code, and its code can be, in this implementation, it can be a reference to the globally deployed contract code, and this globally deployed contract code can be referenced by account ID or the hash of the code. And also the data that we populate into the storage of this contract on the first initialization. And so then we derive, but then we define how we derive the account ID. And there are some unresolved questions here. I wouldn't go here, but like there are some unresolved questions about what the prefix should be, but it should be different from existing prefixes. For example, 0x will be the implicit Ethereum account ID, but we need a different one so that the runtime the near core can understand what should be the costs and the fees, like the storage fees and the gas fees for interacting with this account. And basically how we derive the account IDs, we serialize this struct, then hash it, this serialized value here, take the last 20 bytes, the same for Ethereum, and prepend, like encode it in hex, and then prepend 0s. And the runtime, and then we can make like a lot of magical things. For example, we can leverage that to ensure that the contract that has called us executes the same code as our contract. We're doing this by constructing the initialization state for the caller contract inside of the runtime of our contract, our function call, and then we just make sure that the one who called us, the predecessor, matches the derived account ID from this state. And for every interaction with other sharded smart contracts that follow this deterministic account IDs schema, we need to introduce one more action that actually initializes the states of the contract that we're about to interact with as an action, after which we put all of the actions like function calls that interact with the contract as we want to. And here we just pass this state init, but maybe in serialized form already. And the runtime should ensure that the account ID of the promise that we're creating right now is the same as as what account ID should be derived from this state init. Yeah, and then like a lot of technical details. I wouldn't go into them about refunds, how they're made, how the versioning of the state init is made, and other host functions that we might need and that we actually need for this to work. Basically, this is the only host function besides the promise, the action attachment to the promise. This is the main host function we need to be able to query the code of the current contract that is being executed. in order to verify the caller. And these are just a bunch of like helper host functions that these were never implemented, but some of them are exposed to through the just constant values, but it might be better to actually implement them. And this one is needed to prevent return bomb attack, and that also is present in the NAP 141 standards for regular fungible tokens. So just it's better to introduce it now than never. Yeah, like that's it. And I can talk about future possibilities as well, but is it clear what this proposal is about at this stage?
Yeah, why don't we take some questions and go from there?
Yeah, Michael, you wanted to ask something?
No, I just wanted to say great job. Yeah, I think that was a nice summary.
Thank you. All right. Yeah. So as for the alternatives, we had the sharded contracts that was initially proposed in the NAP 605, and in comparison to this proposal, the sharded contracts or sharded context is also nice, but it has two big limitations. First of all, is that we divide all of the smart contracts in two worlds in this approach, in the sharded world and not sharded world, and unfortunately, they cannot interact directly with each other. But there should be some router contract that is the only one who allows to proxy all of the calls between the sharded contracts and not sharded. But then it starts to but then the question rises, like, but this makes interaction from sharded world to non-sharded completely non-sharded, because all of the calls should go through a single contract that is deployed on a single shard, and therefore we're just hitting the throughput of that single shard. And the second issue with this proposal is that with this one is that the compatibility issue. Like, there is, if you try to implement a sharded fungible token standard in the using the approach described in the sharded context NAP, then you find yourself in a situation that you need to design such a sharded sharded fungible token wallet contract in a way that it allows user to hold not only his balance, but also all of the balances of all of other contracts and protocols that imply that this user is the only one who can, I don't know, send funds from his wallet. Yeah, and more on that can be read in the comments to this NAP, I think, or somewhere in the discussion. Yeah, and yeah, as I've said, the idea was taken from Ton, but actually from like it differs a bit from Ton's approach, because I think what sets Near apart is that in Near you can have chains of promises, while in Ton you don't have that. In Ton, the only option to understand that your cross contract call failed is that the message that you've sent to this smart contract that is sent back to you, it's bounced, and you just have the flag that this message was bounced. And so it leads to the fact that you cannot refund, really, because the amount, and one of the reasons for that is that the amount of gas attached to the refund message is only enough to actually send the message, but like the amount of gas that you receive in this handling of failure function of your smart contract is very, very low. You can't do really anything with it. And but in Near we can create chains of promises, like call this contract and afterwards check the result of the promise and then do something. So it allows for refund mechanics, and yeah, it's like much I don't know, like much easier for developers to design protocols. Also, the another implication is that in Ton, if you do not attach enough gas, there is no difference between gas and attached deposit in Ton, but still, if you don't attach enough tokens, then your transaction fails in the middle, and it cannot be recovered anyhow by any of the contracts that were mentioned in this chain of calls. And that's why like they calculate every milli nanoton to send over on the client, and like sometimes things can go wrong, and that's why they just add 1 ton on top of every call just to like make sure that it will be delivered. So I think Near is better in this perspective. And also another different thing is that the wait a second. I had something in mind, but I forget what was it. Yeah, the refunds, and then okay, never mind. Yeah, so the what can be done after we approve this proposal, I hope we will, is that first we can design sharded DeFi protocols, and we should start from a sharded fungible token implementation. And I've done some effort in this direction, and yeah, I think it's here like only the change in the nearest decay. I've implemented only the nearest decay part, but thanks to Jacob, he was working on the near core part and the other crates that are dependencies of both of them. Yeah, so we start from sharded fungible token. There is already an implementation that I wasn't able to test because the near core isn't ready, so I don't know if it works, but just based on the code, it should. Yeah, and what can come next is I'm very bullish on this one. So wallet extensions. There were a lot of talks recently about how we can enhance the account abstraction on Near, and for example, Near Intents, that's the one of the protocols on Near blockchain. It showed really well. One of the reasons for it is that it supports all of the wallets. Basically, you can interact with this protocol and sign messages with Ethereum wallets, Near wallets, but that's okay because Near already supports this too, but also Solana wallets, Stone wallets, passkeys, when you just touch the Touch ID on your computer and magically your intent is applied. So I think that if we let smart contracts to verify signatures and keep track of the nonces, then it's much easier to upgrade just a globally deployed smart contract that implements some kind of wallet rather than asking for a protocol upgrade, like for the whole Near protocol. And this wallet contract, it can support a lot of wallets from a lot of ecosystems, and it can have like it will be basically a smart contract that implements this signature verification logic and non-striking logic, but also you will be able to install some arbitrary plugins. By just installing a plugin, I mean just whitelisting in like there will be a field in the contract in the Rust structure that defines the storage layout of the contract. There will be a field like what account IDs can send transactions on your behalf. And then if you whitelist some account, by default it's empty. But if you whitelist some account ID, and this account ID turns out to be another smart contract implementing social recovery function or two-factor authorization or whatever, you can just nest these things, and this creates a lot of nice improvements to the user experience. And yeah. But in order to achieve this will be achievable from day one, except for paying for gas. You will need some relayer so that you can sign, like if we approve this proposal, the NP 616, you'll be able to write this smart contract, deploy globally, then deploy per user wallets that use this globally deployed smart contract. And how it will work is that you find someone who the relayer who has the account on Near, and it says that, okay, I will sign a transaction that will pay gas upfront for your transaction only if you send me the signed message that shows that you will pay me back this amount of like equivalent amount of Near that the gas that I've paid for you. But relying on relayers is not the best. Like it would be nice if we can allow for doing this without a relayer. So for example, if this wallet contract, I'm not talking about sharded fungible tokens, I'm talking about like per user wallets, like EOAs, but now they are contracts. If this wallet contract just has Near on its balance, then it can pay for its own transaction, for its own gas. So maybe we can introduce also some new kind of a receipt that doesn't have any predecessor. It's like none. And what the validator will do is that it will load the WASM contract, the contract code, load the storage, process this external call to this smart contract. The smart contract will verify the signature, increment the nonce, whatever, and then it will create promises to like calls to other smart contracts, and that's what the transaction begins with. But I don't know if that's completely possible in like current Near's architecture, but yeah, but that's how things work in Ton, and they showed really well because they can upgrade these wallet contracts. They can introduce these nice features and as social recovery, two-factor authorization, and etc. And yeah, I think like this is about the composability part, and yeah. And what else? The colocation. I had a lot of pushback on that. So like Michael and Jacob were saying that Near is designed in a way that it will never consider organizing shards in some way that that will never consider balancing all of the account IDs on shards in some way that some account IDs are closer to each other than other ones. So I think, yeah, like it should be an NP problem to solve when you try to organize this graph where everyone claims that, hey, I want to be close to this contract, and this contract claims that, like, one at the time of deployment, it wanted to be close to this contract, and then you just start to think, okay, like, even how do we design such an algorithm that does that? But that's just was my suggestion. I don't know if it will be ever implemented, but that might be needed for reducing latency, so that every time that I send, like when I'm from my account ID, like that I control on Near, when I interact with my sharded fungible token wallet, it would be nice if this interaction doesn't take like a second, but it takes less than a second. And yeah, like if we could have located them on the same shard, then it will be awesome, because it can be even be processed in the same block, I guess. Maybe I'm not sure about that. Yeah, but again, this might be not possible because of the dynamic resharding thing. Yeah, and the last but not least, there were a lot of talks about the storage model that is right now used by Near, and as far as I understand, like there is an economic how do I say that, economic mismatch, because you pay only once for storing something for eternity, which is not how the world works, because usually you just rent some storage from big companies like Amazon or whatever. And there are some blockchains that use this renting model for the storage. For example, Solana and Ton as well. And but the obvious question that comes to mind is that, okay, if you want to pay like rent, like let's say that once in several epochs, we subtract from every account that is still active some amount of Near. So what happens if this account doesn't have enough Near to pay for its own storage? And the idea is that like the same way that zero balance accounts exist, you don't need to pay anything to occupy 770 bytes. Then the same idea can be applied here, that okay, if your account doesn't have enough Near to pay for it, then let's say we're waiting for 2 more epochs, just to give the user like enough time window to react on this. But then after some amount of blocks, some number of blocks, we say that, okay, we hashed the current state of the contract, and we put it instead of its current storage. So the storage now consists just of a single hash. And then you like, and this account becomes frozen. And what you can do to unfreeze it is you can pay Near and get from somewhere the state, and the validator will ensure that the hash of the state indeed is the same as as the stored one, and that's how it restores the state, because you now supplied Near. So that's also the idea, but it's not directly connected to this NAP. So yeah, I think that's it. Yeah, and one of the beautiful things is that the deterministic account IDs are fully backwards compatible with existing ones, meaning that you can interact from non-sharded contracts with sharded contracts and vice versa. Yeah, what else? And this one also worth highlighting. When like right now, contracts can log some events. Like basically they're just bytes, but then we have this format for events, event JSON colon, and then the JSON. So when you build an indexer, this indexer tracks all of the events that were emitted by some specific smart contract, by some specific account ID on here. But when you think about sharded contracts and sharded protocols, then indexer, it doesn't know what to track. It doesn't know all of the account IDs that will be the ones who this indexer is interested in. And that's why all of the indexing infrastructure should, I think it should support the stateful, like it should implement some stateful approach where it just has a forever growing map, the sets of, let's say we want to track fungible token transfers. So we want to track all of the minters, that's the account who can mint some tokens, and then all of the sharded fungible token wallets, the contracts that has that have ever received these tokens, because then you need to index them, because they might send to some other contracts, and you just add them to the set of all of the contracts that you need to index in order to just keep track of all of the transfers of some particular token. Yeah, but I think it's unavoidable. Even like, it's not about this proposal, it's about sharded contracts in general. Like if you have just like your functionality is of your protocol, for example, the fungible token protocol standard of the token, if it's just distributed across a lot of contracts and you don't know which contracts will be created, then you don't know which contracts to track the events coming from which contracts. Yeah. And what else? Majority of these questions were resolved in the comments, the unresolved issues. I'm not quite sure that the refund mechanism is very flexible in this NAP. I think it covers like the current needs, but we haven't built a lot of DeFi protocols with that, and basically not only DeFi protocols, but sharded standards with it. So I might be wrong that this approach of refunds will be like sufficient enough for all of the use cases. So maybe someone here can raise their concerns about the refunds part, but it's like, compared to other approaches when you call some function in order to refund, this one is much easier because it has the gas guarantees. And yeah, so yeah, I think I'll stop here. Sorry for taking for too long. 40 minutes. Wow. Yeah. Questions, comments? I don't know. How is it supposed to go?
Yeah, next step is going to be so we don't, I think, have everyone here, but we can kind of do initial feedback and vote if you're able to. Then obviously the rest of the votes can be offline, asynchronous.
Okay, I thought the voting like, is this the voting or no?
Yeah, I'll speak briefly as, I guess, the only present working group member here. Yeah, so the voting indications there, I think are the voting indications that we would expect if Marcelo and Bowen were here. I think they would vote yes. So I think it is okay to take those as being legitimate thumbs up for the purposes of the process here. Obviously, mine as well. And we didn't end up hearing from Marcin, which is not strictly necessary. I believe we do just use majority voting here. So 3 out of 4 is enough, sort of regardless of what Marcin ends up voting to pass this. So that's exciting. Officially, I think this does mean that it does pass. Although I would be interested in getting some feedback from him. He normally has some pretty thoughtful insights, and sort of polishes NEPs in a nice way. So if we could do that before this is all finalized and shipped, I think that'd be cool. Pending his availability, obviously. The only other comments I want to make about this, because we did sort of have an async discussion among members of the working group last week / earlier this week, and some things that were being raised about this are it not being particularly Near-esque, right? The way that this works, ultimately, one of Near's primary features is the named account model. Having these nice human readable names is useful, but the sort of counter argument is that the sort of useful human readable information is present, just not on the ID itself, right? The ID is sort of a hash of things that could be presented in a nice human readable way. So I think given that this is approved, it would probably be nice to see some work on the Explorer side of things to be able to expand, for example, what the state init action details were for a given deterministic account ID. And that would go a long way into making these things a little bit more friendly to look at, just from a user perspective, because obviously, the elegance of capturing the code plus initialization in a single cryptographic hash is great for a protocol like that. That works really nicely. It works really great for contracts, like you were saying at the start, Arseny. Confirming that they're running the things that they expect and that they can trust each other. That's all excellent. The backwards compatibility of this, also an excellent feature that the original sharded contexts was a little bit less good on. So yeah, all of the positives we agree as a group do outweigh the sort of, I guess, again, non-nearish nature of the thing, and again, can be made up for by some work on the Explorer side. So I think that would be cool. As for some of the stuff you mentioned at the end about dynamic resharding versus close to and sort of storage work, etc. I think those are discussions that have been ongoing for a long time, and I think will continue to be ongoing for a long time, if we're being honest. So, looking forward to continuing those discussions with you, Arseny. Obviously, you getting involved here with deterministic account IDs for pushing forward sharded contracts was great. So, yeah, having you involved in future discussions about how storage evolves or how dynamic resharding evolves would be cool too. So I think that's about it from my side. Again, just to summarize, this is approved. Yes, exciting. And we'll try to sort of polish up some of the last remaining open threads, but it'll go through. I also wouldn't mind, Jacob, if you have anything else to say, hearing from you from the implementation side, on the Near-core side, if there was any sort of snags that came up during your implementation work that maybe need to be addressed here.
Yeah, sure. So just briefly for context, so I've been working on the Near-core side implementing this. I've worked on the previous proposal as well, together with Aki and a lot of other people that were involved, and we were basically ready to finalize this sharded context implementation when Arseny came in with this, in my opinion, strictly better proposal to solve the same problem. And we're super happy. Thanks a lot for coming in just in time. And it took a bit for us to understand that our previous proposal wasn't quite as good, because we were kind of already ready to ship. But now I've also implemented the second part. Again, many people have been involved in the design. I've just kind of written it down in code and made sure it actually works. Now, comparing the two side by side, because I have both full implementations, I can say this is a much smaller change to the protocol, which is really nice. The actual deterministic account is like a super small change. It's just a verification on transactions change. So we have a new type of action that comes in, and we have to verify that this is correct. The execution is pretty straightforward. And when we execute, we don't even have to do any checks because we all do it on the sender side. So this is pretty nice. I think the only condition where the execution can fail is if there's not enough storage. And yeah, I'm not going to open that whole discussion again. Storage isn't ideal, but maybe future changes can make that work. But right now, we just keep the storage model as it is, and I think that that's great. We really have to like the small change in the deterministic accounts. What's worth raising is that the most of the actual changes we have in Nearcore now are related to the host functions that we're adding that go along to support this feature. So in the past, we often had like specific NEPs just solving one specific feature. And then if we needed something to support, that would be like a separate NEP. Here we have this all together, and I like this approach. We have a goal of what we achieve, and we bundle it all together so that it's actually useful. I think this is because Arseny has like a good view on how to actually make things work, rather than just a protocol view of like where do we have to pull which lever. So this is good, but it means that now we have lots of changes specifically around the refund to host function, which redirects how after a failure, the refund of that attached balance, where this is going to go. And I think we need it. I'm not going into technical details. It's important to make this feature work, but this actually required us to change the action receipt structure, which is something we have never changed ever since the launch of Near. So it's like the first time we introduced a versioned field of that, and there's like lots of code changes. And Anton, who's also in this call, has already reviewed it, and we have tests for it, and like we're ready to ship this. But that's probably the most interesting thing I can add at this point. This is what caused the biggest changes to the protocol in terms of actual code changes, and the feature itself is really small, and I think that's just a good sign. Everything else is just sort of our protocol showing that it has sort of holes that we need to fix, and we are fixing all the holes that are specifically needed to make this work, and that's just naturally additional work. By the way, can we add env-get refund to account ID function as well? Can you explain what you mean? Yes.
There was a question from I didn't remember the name of the guy. The first reviewer. So he was asking about the init function instead of init storage, and then I realized that some smart contracts might want to understand what account ID will the funds go if it fails, and we can use this refund field that is set for the current receipt for all of the refunds, because otherwise I would need to duplicate this information inside of the payload that I'm sending to the contract, while like it seems that the majority of the standards, the contract standards that will evolve, will likely need to refund to the same account that Near will be refunded in case of failure or in case of already deployed smart contract. Yeah, so maybe we should add it as well, because it's a relatively small change, I think, as well.
Okay. Yeah. So are you asking that a smart contract should be able to look up what the predecessor sent the refund to field, so that it can kind of forward it again?
Yeah. This might be useful if the contract itself wants to do some refund logic from its execution. So I don't know.
Yeah, I think that makes sense. It's not included right now. It's an easy thing to add. If we add it, I would ask you to also add it to like the NEP proposal, so it's kind of all written down there. Yeah, from my side, it makes sense to add, but probably it should be like written down, and also people who are not in the call can kind of raise concerns if they have it. Yeah, but from my point of view, technically, it makes sense, and I would also vote for doing that if we can.
Cool. And by the way, answering Michael's question about not nearish account IDs, like the near account IDs were like it was possible to have them named. I think names should be implemented as NFTs, like the ENS service, the same way how it works. You just create some NFT collection that is .near, and you let others to derive to create accounts and to transfer ownership of these accounts. And by the way, this can create a market that you can sell your name and you can buy yourself a name. Yeah, like it may be easier for the developers to understand these names, but still where the developers not like grandmother will never use near CLI to send funds to USDT.tether token.near. She just sees the wallet application on her phone and just taps confirm. So I think, yeah, that's like we are going away from named account IDs, but I think it can be still implemented as an NFTs, and we don't lose anything by that.
Well, yeah, I don't want to derail the conversation any further. Yeah, there is actually a service that you can buy and sell near names already, because the near name is a contract. So there, you can actually do that. It's been around for a little while now. I forget the name of the website, but you can actually do that on near.
But it means that I'm also selling all of the tokens that are owned by this account ID, right?
Or the contract, right?
Yeah. But what if I am a member of DAO? I can't really sell my account like name because
Right. Yes, those scenarios. Correct. Yep. Totally. Cool. This was great. If there are no other further questions, I think we've come to a resolution. So this is approved, and those steps are there. For posterity's sake, this will all be listed here, and we'll also publish this video as well on the YouTube account. Jacob.
One thing I want to make sure we kind of finalize in this call. What is the prefix for account IDs going to be? We have 0s in the proposal. I've implemented this way. It seems fine to me. Maybe Michael, what did the working group say? What prefix should we use?
We didn't bike shed on the prefix, so maybe we should have. 0s sounds fine to me. Like S for sharded, whatever seems okay. I guess. Yeah, it's already implemented that way. Let's stick with it. I don't see a reason why it shouldn't be done that way. So yeah, that seems okay. We'll just agree to it now, and anyone else can forever hold their peace because they didn't show up to the call.
Yeah, that's fine with me. Anyone I talked to was like, yeah, it seems important, but actually I don't care. Like, it just has to be unique. So yeah, okay, it was there out for long enough. I think nobody had a very strong opinion, so let's go with 0s. Yeah, fine by me.
And one more question: what do we do next? Like, there is still a bunch of. I didn't resolve any of discussions because I think they're important for people who are reading this proposal, and like most of the discussions were resolved. Like from my perspective, we came to a conclusion on each of these questions, but like I understand the part about adding a new host function get refund too. I'll do that, but should I change anything more in the text of the NEP, or should I remove these, for example, unresolved questions? Yeah, like
Yeah,
Yeah, anything that is now resolved, I think you should remove from, or like maybe not remove, but like add what the resolution is, or like maybe change the heading to, I don't know, discussion questions or something. And yeah, we do want the final NEP to be in a form such that it is good enough to be a specification if someone else was building another near client, right? That is the standard that we want to hit. Some of the NEPs do better than others, but yeah, if it has all of the details necessary for someone else to do the same implementation that Jacob has done, then it's complete.
yeah, cool. So I'll rename, I don't know, remove some of these issues, but if we go one by one, did we answer all of them? Like the zero balance accounts, I get it. Like if the account is less than 770 bytes, then it's a zero balance account. All right. So non-refundable storage staking, we don't do anything about it, right? Because it was never implemented, I think. Yeah. Forwarding amount from state init action as attached deposit into later function calls instead of refunding this immediately. This happens. For example, I'm initializing the SFT wallet contract of the receiver, and I'm putting there, like, let's say we don't have zero balance accounts, and I'm putting there 0.5 near, and then it turns out that it's already deployed. But what if the function call that happens after it's like receive, and then it notifies the receiver? What if it would be grateful if it can use the amounts that was attached to the state init instead of refunding the amount that was used before the initialization back to the refund to set it on the that was set on this receipt? Do you understand what I'm asking about, Jacob or Michael?
not quite.
I think I understand what you mean, but that sounds complicated. I think it is better for the protocol if actions are, for the most part, atomic, as in like they are self-contained, they do what they do. If you have actions that are influencing future actions, I think that can create some potentially unforeseen consequences in terms of spooky action at a distance kind of thing. Like, where do these tokens come from? Who knows? Yeah.
I agree, because you don't know whether this contract exists or not. That's why you're attaching the states in it. And what if you wanted to swap near for something? Then you're just adding more near, but you're expecting the same output. So
Exactly. Yeah.
yeah. All right, and the last one, refunding via plain native transfers. So I think we agreed on the fact that refunding with a function call, like when you actually call some smart contract with a special function, receive refund, that seems a bit weird, right? Like or non-determined, like it doesn't have the gas guarantees. It's more complicated, and we don't know how to express that this particular action failed. What you should forward back all of the arguments of the function call name, all of the arguments that was supplied to it, so that the contract that is handling this this refund can act on this, right? So it seems also complicated. So do we drop it here? Like, just no?
Yeah, I think it's better if refunds are simple transfers. That's already how refunds currently work. I think it's better to keep it consistent. And again, it's also complicated from a security perspective, right? This is a problem on Ethereum endlessly, right? Where you can trigger logic by sending tokens. Like being able to do that is an additional piece of complexity that often creates security issues. So I think not being able to do that on Near is generally speaking a good thing, and I think that should be true of these refunds as well.
Okay, good. And one more question to Jacob, I think. When you're, I think that there was a proposal that reduces the number of the refund receipts because you process gas refunds and failed promise refunds in a single receipt. So now, did you decouple them? And like the question is, what if I am paying for the gas and the set refund to was used in some of the subsequent calls between the smart contracts, and then some of the part will go to this smart contract that claimed itself as a passed itself in the set refund too, but the gas refund will be given back to me, right? Or no? Like, how does it work?
Yes, what you described, that's how it works. To elaborate briefly, there was this recent change that reduces gas refunds. It tried to do it in two different ways, and one of them was retracted. The one that's remaining is we no longer try to, like, we changed the gas price that we use to charge at the moment of execution, and previously we were like attaching more. We purchased gas at the higher price than it was right now to accommodate with the fact that during execution gas prices could go up, so that's more Near token per gas unit, and that meant that in most cases it didn't rise, or it didn't rise as much as it could have. So in the end we paid too much for gas and we had to refund that difference. Now we just say, well, we just always use the gas price of the start of the transaction, and then we don't care about this increase, and therefore we don't have to do all these gas refunds. So that's kind of unrelated to this change. What this change, however, does is it increases the number of refunds, which is counter to what we wanted. So we have a new way of making refunds, and that's after trying to initialize deterministic account ID. When it was already initialized, then we will refund the balance that was attached to it. I discussed it with a few people. Nobody seems to think this is a big problem, primarily because we're actually going to pay for this refund, whereas the refunds that we removed, those were kind of for free. So they were like, the gas was for the refund itself was purchased as the price of 0, so we subsidized it for no good reason. Whereas this one, we actually pay for it in gas fees by the people calling it. It's a significant amount compared to like the full cost anyway, and I think there's not much to be complained about. Sure, we could make it slightly more efficient by not having this refund, but it would be drastically less usable. So if you want to have this lazy initialization, you should also pay for you should also have the ability to refund. So lots of extra information. Did I actually answer your question, Arseny?
Yes, thank you. All right, so we're good. I think all of these are resolved. I'll clean them, or maybe, I don't know, maybe provide the answers, like FAQ section, frequently asked questions. I don't know, like I'll do something about it. All right, and after that, this will be considered as ready to be merged or what? And then we can start to work on the sharded fungible token standard, right?
Yeah, so from my point of view, these things can kind of overlap a bit. So please clean up this NMP, make sure it's in a final state so that we can like archive it and people can have this as reference for what it does. But we will already, after we have like official approval, we will start actually merging this into Nearcore. The goal is to have it all in by the end of the week and have it ready for the next release cut. That would be awesome if we can get that done. My opinion, it's okay if the NMP is not merged by then yet. There can still be some sort of ongoing discussion and potential changes, but like we know what we want now, so we can actually get it shipped. And then the next step of actually making the contract standard, which needs to be built on top, I mean, it has already started the discussion, and you can already start writing things more down. And yeah, so there's some overlapping here. From the process itself on the NMP when it's merged, I think maybe, yeah, other people should comment on that. But from implementation point of view, I no longer have a blocker. I will just get it done as soon as possible.
Nice to hear. And the final question for me is that in the NMP itself, I have a lot of links to, as you can see in the bottom left corner, to my draft pull request in nearest the KRS. Is it a bad thing to like? And you can see that a lot of links. Like, is it a bad thing to have? And should I just remove them or just keep them because someone can just understand what I'm talking about? Because the pull request in nearest decay, it's not in the state when it can be merged. You see?
I think it's fine to keep it there. Just please don't delete your branch. It does have like the git hash and also you can't modify it, but if you delete it, the link will be dead. And usually what we do in that case is we use the Internet Archive to find it and maybe add that link. But I don't know. Maybe someone else has a strict requirement, but I think don't make your life too hard here.
Okay. All right. Thank you. I don't have any questions left.
All right. Awesome. This was a great presentation. I appreciate everyone's time today, and we will see you next time. Great. Take care, everyone.
See you. Bye-bye.
Thanks,
Thank you, everyone.
Bye.
Bye.